All right, what's going on, everybody? Ryan Ogren here, and today I'm going to be going through why AI data centers need so much power, okay? We get this question a ton from private equity, VC folks that are outside the industry trying to get into the industry, maybe energy guys that are very good at building power infrastructure and power solutions but don't know too much about the data center game. So this is videos for you guys. Also for professionals that are looking at the AI data center space and wondering why it's so important and why they need so much power. So this video is for you. For those that don't know, I'm Ryan Ogren. I'm a private equity investor in the data center infrastructure and power infrastructure space. We've been behind some of these major projects that you've seen announced. We can't quite come out and say that we've been behind them just yet because the NDAs. When that time comes, we will be the first to let you guys know, but I'm making these videos for two reasons. One, I had to learn the industry for myself from the ground up, but it's possible. And we're about to have a massive staffing shortage of young, talented people getting into this industry. They think it's too hard. They think it's too challenging. They don't even know it exists for the most part. And I'm 28 as of making this video, and we need more 28-year-olds, more folks in my generation, because we're building assets that my generation is going to have to take care of. Most of the guys that are doing these deals right now, 40s and 50s and 60s, these guys are going to retire. So we're building power plants that are going to be around for the next 40 years, and they're going to be long gone. We're building data centers that are going to be around for the next 100 years, and those guys are going to be long gone. So it's my generation that's going to be able to take care of these particular assets. So we got to learn about it, right? So that's one. And two, deal flow. We want to connect with other investors. We want to connect with other developers. We want to connect with folks that have deals and need our expertise to get them across the line and close. We want to connect with people that are doing power infrastructure as well, just because there might be a joint venture opportunity as well. So if you have a deal or you have something you want to talk about, I'll put a link below where you can go to our website and contact us, or just drop a comment and we'll reach out to you. Those are pretty much the two reasons. And without further ado, let's get into the video. So make sure you like and subscribe, because this is a new channel and you don't want to miss anything. Turn the notifications bell on and let's get into it. Why do AI data centers need so much power? There's 4 reasons, okay? 1 is GPU power. 2, 24/7 maximum load. 3 is cooling systems, and 4 is scale. And I'll go through each one of these more in depth, but the very first one is GPU power, all right? I'm sure you guys all know NVIDIA, right? And they just make all of these chips. Now, the chips that they're making are GPU chips. These GPU chips they don't work like a traditional computer chip. Traditional computer chip is a CPU. CPUs are sequential chips. They do one thing at a time, and then that's pretty much how they operate. It's one thing at a time. GPUs can handle like a million different things at a time, so they just operate much faster and they consume more power. But the GPU is required for AI workloads. CPU and AI can't use that CPU. It operates way differently. So the thing that really is enabling AI are the chips. And that's why you see NVIDIA's stock go crazy. And that's why you saw it go crazy a few years. So this is pretty much the main difference. GPU requires much more power, almost 10 times the amount of power as a CPU. But I think it says 5 to 7 times. So then when you actually break it down, these chips, the power scales exponentially. So the chips go into a server, and then the servers go into a rack, and they have all these different servers lined up on top of each other in a rack, and then they have all these different racks in a data center hall lined up on both sides on different aisles of racks. So the power of this really adds up over time, okay? So you have, once again, you have all these chips. I think you can say 8 chips go into a specific server, into one server, and you have 10 servers in a rack. You can see how that power consumption actually works. And it really comes down to the chip on that particular one. One AI data center can take up a ton of power, and that kind of leads us into our next point. These data centers are 24/7. So 24/7 maximum load. There's no downtime. It's continuous operation. Most of the load is actually coming from training these AI. So they're constantly training these AI models because they're racing to get to AGI and SGI. AGI is pretty much when AI, AGI is pretty much when AI doesn't need humans anymore. It's smarter than a human, and it can complete the task better than a human can. There's arguments that we're already at AGI, but when you have to prompt AI, and then you have to fix their prompt, and you have to tell it, remove the hyphens. All you guys out there that use it for emails, I do the same, so no hard feelings. But AGI is when it already does that and does it better than a human does. So that's that. And then SGI is super intelligence, and there's theories around this that we're not going to even be able to understand AI at that point in time, because it's going to be so much more advanced than humans are. So that's scary, and that's really when people think AI is going to kill us all. But I don't know. No comment on that. We're just building it out. I don't think you can slow down the AI race. I think you can only try and make it more safe. 24/7 maximum load, because everyone's racing to get to that particular point in time. They're training these models. And there's also theories that a lot of these big AI companies have AI, internal AI that they're training, and they're not going to make it available to the public because it's going to be such a strong asset. So there's also that theory as well. So that's I'm not here to spread propaganda. These are my own opinions and my own thoughts. Okay. Number 3 is cooling systems. So now we know that these GPUs, they take up so much power. Okay. So that we get all the power to the site. GPUs are using all this power. When they use the power to actually compute, it gives off heat. So we need a substantial amount of cooling. And they're used to traditional AI data center, or traditional data centers, not AI data centers. They use air cooling systems. And air cooling systems like heavy HVAC, all that, it's solid and it works. But these AI chips, these GPU chips take up so much power, they generate so much more heat that air cooling doesn't actually cut it. So we actually have to use something called liquid cooling. And liquid cooling is a tremendous strain on the infrastructure of the data center. So liquid cooling, you have to then get so much more water to the site. And it's also another constraint of when it comes down to site selection, if you can actually put an AI data center here or not. So this is some of the issues that you see in like Arizona and even West Texas. So they're having to use a lot of water infrastructure out there to get these deals across the line because there's a lot of the cooling systems are very important, and you have to have liquid cooling in an AI data center to cool it down. But you're also using power to run these cooling systems, right? So having these cooling systems run, they don't just run by themselves. You have to use a little bit of power to run these cooling systems. So that's another big point of why these AI data centers need so much power. And number 4 is there's these AI data centers are much larger than traditional data centers out there. You see these hyperscale campuses. Look at the Meta one that they announced in Louisiana. That thing is massive. It's as big as Manhattan. I'd like to see a traditional data center that size. So these AI data centers, not only are they consuming more power, not only are they more power dense per rack, that means there's more power being used in each server, in each rack, and they need more cooling, but they also are just much bigger. So that's pretty much the biggest thing between data centers and why they need more power. These are the sources I used for this video. You can check that out. And if you like this video, subscribe. You can follow me at Ryan Ogren on X or Twitter, or connect with me on LinkedIn. I'm very active on LinkedIn and Twitter. And then obviously subscribe here. This is a new channel. So if you guys like this, subscribe, and I got more coming. All right. See ya.